So we're going to do this lesson flipped, which means you're going to watch it at home, learn it at home, take notes at home. That'll be your actual homework. So we are dealing with linear inequalities. This is section 2.8. It'll be the next section on your new syllabus that I give you tomorrow. And this has to do with less than's, greater than's. So let's just start out naming them. If I am open to the left, that is a greater than. If I'm open to the right, that is a less than. If I have the line underneath it, that is a greater or equal, or a less or equal. Okay. Now, if I am going to graph these, I can't just think about open circle and closed circle because I'm graphing lines. So if I don't have the or equal to, and I'm just a less than or greater than, what we're going to do is dash lines. If I have the line underneath, the or equal to part, our lines will be solid. Okay. Now shading, we can always use a test point, and I'll go over that in a minute, but shading, if we're solved for y, if I have slope-intercept form, we can really think about shading either up or shading down. So if I'm a greater than, I can think of shade up, or greater or equal to, I can think of shade up. If I have a less than, or less than or equal to, I can think of shade down. So I can make some examples really quick. This would look like a dotted line. If it's shaded up, it would look something like this. So that would be my solution region. If I had a less than, again, I have a dotted line, but this time it would be shaded down. If I had a greater or equal to, have to be a solid line. If it's greater, I'm shading up. If I have less than or equal to, solid line because they were equal to, and this time I would shade down. Okay, so we can talk a little bit about what is a linear inequality, what is the solution, or how do you find the region. So I'll zoom in a little bit here. So down here, a linear inequality is an inequality that has two variables, not the ones we solved before with only one, that we would put the answer on a number line. We have two variables, they're going to go on the coordinate plane. The solution then is the shaded region, so it's made up of all points that are in the shaded region. Or if it's a solid line, then the points on the line are also solutions. Okay? We can always find the solution region by using a test point. Okay? And I will show that in a second. But a test point is if you sub any point into your inequality, and if the point makes the inequality true, then it should be part of your region. So if it's true, you shade that side. If it's false, you shade the other side. And we usually use 0, 0 because it's the easiest. Sometimes we can't use 0, 0 if 0, 0 is actually on the line. So let me pull my view back to what it should be, and we can do a couple of them. Okay, so for my first example, this is just basic slope-intercept form. My m is 2, my b is 3, so I'll start and make a point at 3, count a slope up 2 over 1, maybe I'll go down 2 over 1, a couple more times. I need a dash line, so I'm going to connect with a dash line. I should use a straight edge. And then now, I could use a test point. So if I would use a test point, say I would test 0, 0. I would put a 0 in for y, a 0 in for x, and then analyze this. Is 0 less than 3? This is true. So what it means is I want to shade the side where that point is. Because I was in slope-intercept form, I could have just thought, oh, this is a less, I can shade down. That would work too. For my second one now, I'm in standard form, so if I think of my intercepts, I'm going to have an x-intercept of 5, 0, and a y-intercept of 0, negative 2. I can throw those on. Here's this one, and this one. How do I connect? I need a solid line. But now I can't just think of shade up or shade down, so I need to test. I need to test a point. Again, I'll use 0, 0 because it's a nice easy one. I'm showing my work here, but you wouldn't have have to because basically you're just throwing zeros in. Is 0 less than 10? Yes, it is, so that means I'm going to shade this side. Now I have a star down here because if you would have solved this for y to graph it, and I know some of you still like to do that, you need to be careful at this step right here. Right here, I'm dividing by a negative. I have to flip my inequality. Okay, so this star here is for a flip if multiply or divide by a negative. If you forget to flip, your line will probably be alright, your shading will be wrong. So make sure you're either using a test point for your shading or don't forget to flip. Okay, so for my last one, here I'm going to have to divide by the negative. So again, I have to remember to flip. I have x is less than negative 3. I need a dashed line at negative 3. And I need to shade. Less is going to all be on this side. Okay. So those are some example graphs. Oops. Don't want that. I do want that. No, we'll skip that one. So here, some of it is, can you write the inequality for a particular graph given to you? So you have to kind of piece it together. If I look here, I can see that the b is 4. I can count my slope. Looks like down 1 over 2. So my m is negative 1/2. I can put these together. But I need to think about my inequality now. Now I know it's dashed, so that's telling me I don't want the or equal to, and I know I'm shade up. So I want a greater one. Again, we can test. So if I test 0, 0, 0, 0 should not work. So if I put a 0 in here, this is saying 0 is greater than 4. This is false, as it should be because that's not shaded there. So you can kind of put your pieces together and write the equation given an inequality. The last thing we can do is word problems here. So here I have the memory card for your camera has a 256 megabytes of memory. Each photo takes either 1 megabyte or 2 megabytes depending on the resolution. We want to model with an inequality, and then we want to find some solutions. I have no clue what that is doing there, so we're going to get rid of that. That was supposed to be a picture of a camera. But anyway, so we need to decide on some variables. So how about I use x and y, just to make life easy. X could be number of 1 megabyte pictures, and y could be number of 2 megabyte pictures. Okay. So now I know I have 256, so if I have 1 times x, because 1 megabyte times however many of those, and 2 times y, 2 for each one of those, if I add those up, I know that has to be less than 256. But now think about this for a second. Could it be equal to 256? Sure. That would just totally max out my memory card. So how do I want to do this? I definitely want to think of intercepts. I don't want to solve for y or anything like that. So if I put a 0 in for y, I'm going to get 256 for my x. If I put 0 in for x, I'm going to get, what, 128 for my y. So here I can label this number 1 megabyte picture. And this is number of 2 megabyte pictures. I should probably think about how I want to graph this. I need to get to 256, so maybe 50, 100, 150, 200, 250. I And then I know my intercept is 256, maybe I'll write that on here so I remember. And I'll do the same, 50, 100, 150, 200, that's enough there, so I'm going to show 128 here. Might as well show it. I'm going to connect in a solid line. I'm shading below. So anything in here is a legitimate answer. Now I know I don't have graph paper, but I can still pick out some possible solutions. So I could say this point here, I could say 51 megabyte and 52 megabyte. I could do that. I could do something like 102 megabyte. Or I could use one of my intercepts if I really wanted to. I could say 256 1 megabyte pictures. The beauty here is there's infinite solutions, infinite possibilities, because everything in the shaded region works. Because I have a solid line, the points on the line could also work. So that's a quick review. Hopefully you took notes if you needed to. If not, you should understand how to solve any inequality that answers a region. And we'll be working on this tomorrow. So thanks for watching.